Okay, in the first video, when we were using the parallelogram method to add vectors, all of our resultant vectors ended up in the first quadrant here. So we're going to do some examples where it doesn't end up in the first quadrant, let's say over here in the second quadrant right here. And they're similar to each other, but with the references and the reference to the x-axes, like the positive and negative x-axis, we have to take into account. So what we're going to do is we're going to start out with vector A right here, and vector A is going to be let's make vector A 140 newtons. And it's making an angle with the x-axis of 33 degrees. And then coming off of vector A, we're going to come off at an angle of 67 degrees. With vector B, which has a magnitude of 210 newtons. So I'm going to erase that positive y right there so we can see it better. 210 newtons of vector B. So now, with the parallelogram method, we do it exactly the same way as we did before. We're going to come down here from vector B, and we're going to come down parallel to vector B. That looks pretty close to being parallel. And I'm going to draw a parallel vector that looks kind of like that. So that's vector B. And then joining those two here, so we've got vector B going in the same direction that vector B was going in before, and it's critical that you put these arrowheads on them. Vector A in the same direction and the same magnitude as before. So this is our vector A redrawn. And I better put this B over here. There's our vector B redrawn. And the reason why that's critical is because, remember, when we're diagnosing this with the parallelogram method, the resultant is always between where the origins of all the vectors are to where the tips or the points of the vectors are pointing. So I'm going to trace out or draw out our resultant vector here, and it's going to look kind of like this. That's our resultant vector. And we can see already that it's going to end up in quadrant 2. So now, how do we go about solving this? Well, we can use the law of sines, or excuse me, the law of cosines to solve for r. Because we know that the angle opposite the resultant side in this triangle right here is 67 degrees. So we can use the law of cosines, which is a form of the Pythagorean theorem that says r is equal to the square root of a squared plus vector b squared minus 2 times vector a times vector b times cosine of this angle 67 degrees, which is opposite the resultant vector. So if we plug in our values in our calculator, a squared 140 squared plus 210 squared minus parentheses 2 times 140 times 210 times cosine 67 degrees in parentheses equals, and take the square root of that, and I came up with 201.8. So the resultant vector, by my calculations, is equal to 201.8 newtons. So far, everything's exactly as it was for the resultant vector ending up in the first quadrant. Now, what we're going to have to do here is we're going to solve for some angles inside here, and what we're going to have to do is realize that once we get beyond the 90-degree point, we are going to be greater than 90 degrees. In fact, the x value is going to be negative, the y value will stay positive, and that's not going to have a lot to do with our findings, except that we realize that our positive x-axis is always the reference axis that we use. So let's go ahead and say, okay, we know what the B side is right here. B is 210. B is 210 newtons. The angle that is opposite that B side in this triangle right here, we're going to call it angle alpha. So we can use the law of sines that says the resultant vector over the sine of the angle that's opposite the resultant vector, which is 67 degrees, is equal to the B vector divided by the sine of alpha. And then we can go ahead and cross multiply, and we find out that the sine of alpha is going to be the B vector times the sine of 67 degrees divided by the resultant. So we plug in values. B, which is 210, times the sine of 67 degrees equals, divided by the resultant vector, which is 201.8. That gives us the sine of the angle. We hit shift, sine. We have 73.3 degrees. This angle right here, alpha, is 73.3 degrees. Now this is critical that we understand what we're doing right here, because when we add the 33 degrees and the 73.3 degrees, just like we did in the previous example, that's going to give us this angle theta, which is equal to alpha plus that 33 degrees, which is 73.3 degrees plus 33, which is equal to 106.3 degrees. So with reference to the x-axis, we have our resultant vector, which is 106.3 degrees.